Hi there, everybody. My name is Kylie, and we are going to be walking through a tutorial of how to model the production of liquefied natural gas, or LNG, on HYSYS. So the first thing that you're going to want to do, and I already did on my computer, but you're going to want to go into your virtual desktop and you're going to sign in. And then once you're in that virtual desktop using the search bar, you can search HYSYS V14 and that will come up. You'll hit open and this will be what you'll see on your screen here. The first thing that you're going to want to do is click create new case. Now we have a blank case with nothing in it. So we're going to go ahead and follow this step-by-step spec instruction. So the first thing that we're going to do is define the property environment, and we're going to essentially just create a list of all of the components that we're going to need. So HYSYS should already open you up into the components list right here, and you should see what you see on my screen, component list, source. So what we're going to do is we're going to hit add to add new components, and this is what our screen is going to look like. So you're going to go ahead, this is going to be the components in our system, and this is going to be, if we scroll to the right, where we're going to get the components from. So if we follow the list of components that we are given here, you can see, just type in the search bar, nitrogen, then it should highlight the one that you want. If this wasn't the one you want, you would have to go select a different one. But if it's already highlighted, you can just double click on it, or you can hit the add button, and then it should shift over to the left side. Our next one is going to be H2S. Another way you can do it is just hit the return or your enter button, and that'll be the same as clicking the add button. Let me double check. Methane, ethane, propane, butane, and butane, pentane, and pentane, and hexane, and our last one is water. So now that we have our components list defined, we're going to go ahead and call it LNG comps. So we can do that by double clicking this component list. Once you right click it, it'll come up with rename. You can hit rename. We'll highlight this and just do LNG comps. Hit enter or OK. The next is we're going to select our fluid package. So come here to this little tab on the side. We're going to hit add again. And for this one, we're going to come down here and scroll into our packages that we have available and click Pang Robinson. And then once that's done, it should be all blue over here on the left-hand side. Now we can enter the simulation, and this will bring us to our main flow sheet. So the first thing that we're going to do is we're going to want to create a material stream. So you can come over here to your model palette. This is where you're going to find all of your unit ops and create new streams. The blue arrows are material streams, red are energy, and yellow are power. So we're going to start off with a material stream. You can double click it. It'll create a material stream and you'll be able to edit it. So up here, the name, we can click on it once and type sat gas. We're given the temperature, 38 degrees C. Pressure, we have 6150 kPa. Mass flow, which we want to make sure we're in mass and not molar. It's going to be 387,200, and make sure you have the right units, kilogram per hour. Then next, we're going to head into composition, and this will allow us to do the mole fraction. You can also do mass fractions. So for nitrogen, 0.0094. For H2S, 0.0216, CO2, 0.0291, methane is 8249, ethane 0.0808, propane 0.0212, ibutane, and butane. Oh, it looks like we have, this should be N-hexane. Let's go change that. So accidentally we put in a wrong component. We don't want N-hexyl-BZ, we want N-hexane. So what I did was I came back out of simulation and I went into properties and I went back to our LNG comps, and I'm going to show you how to delete. So you're going to click on it. So let's highlight it in yellow like this. And you're going to hit remove. Now you can go back to your list and you see that it's gone. And then we're going to substitute it for N-hexane, which now the proper one is highlighted. You could also use the replace button. And that's another way to do it, but even though we made a mistake, that's a good thing to know how to do. So back into simulation, and we're going to start over with our sat gas. So double click that blue stream and call it sat gas. Temperature, once again, 38. Pressure, 6150. Mass flow, 387,200. Now we go back into composition. Nitrogen, 0.94. And I'm just going to enter these the way that they're given to us in our spec sheet. So you can see at the bottom, this total is going to be the addition of all of our mole fractions. And whenever you have mole or mass fractions, it should be equal to 1. And if it's less than or bigger than 1, then you know you have an issue and you'll have to go back and edit this. So we're going to hit OK. We can X out of this, and this is our sat gas stream is now defined. So our next task is we're going to add a blank sub flow sheet. We're going to call it natural gas purification. So you're going to come over here to your object, your model palette, and here, this top button up here is going to be our, move this up here, our button that we click when we want to do another flow sheet. So we're going to start with a blank. Now we can double click it, edit the name here, and we're going to call it natural gas purification. And we're going to enter the subflow sheet environment with this button down here. Now that we're inside this subsheet, we're going to add a component splitter. So our first unit op, we can search in the search bar, or you can use some of these different buttons that'll give you heat transfer, different things like that. I usually just type in the search bar because it's faster. So component splitter, double click that. And here are our specs. So the name is going to be gas sweetening. Our inlet is going to be our sat gas. Let me double check. that we didn't need to do that earlier. So before we do this, we're going to leave it unfinished for now. We should have done this before, but we skipped this step. But that's okay. It's all fixable. So in your flow sheet modify tab up above, you're going to have, and you might need to expand your screen, a go to parent. This is going to bring us back to where we were before in that big subsheet. And we're going to add in our inlet for external stream sat gas. Now we can go back into our subflow sheet environment, and that'll bring the sat gas into this subflow sheet. And you have this little button in the bottom right-hand corner that will zoom to fit, and it will fit your flow sheet operations so that you can see them properly. So double click that to get back in there. Now we can continue. Our inlet is our sat gas. Our overhead outlet, we're going to create a new stream and call it sweet gas. Bottoms, we're going to call waste. And our energy, we're going to call Q-MEA. Next, we're going to go from connections and parameters. Our waste temperature is going to be 20 degrees C. Waste pressure, 101.3 kPa. Sweet gas temperature, 38. Sweet gas pressure, 6150. We're going to accept the defaults that say use stream flash specs and pressure specs. Next, we're going to go into our split section. We're going to make CO2 and H2S 0. In our sweet gas. And then the rest we're going to put as 1. Now our component splitter has converged, so we should be good to move on to the next step, where we're going to perform a dehydration using triethylene glycol or TEG. So we're going to go back into our properties in our LNG comps list, and we're going to add TEG to our comps. Now we can go back to simulation. When it says, do you wish to be left in holding mode? Holding mode is a mode where you can continue to edit, but it won't save it and it won't converge or solve. So you don't want to be in holding mode right now. So click no. Now we're back into our subsheet. So we're going to add a material stream into our subsheet to represent ethylene glycol. So come back over the blue arrow. We're going to name it TEG feed. Our temperature is going to be 50 degrees C. Pressure is going to be 6150. Standard ideal liquid volume flow is going to be 0.4543 meters cubed per hour. And then we go to composition. We're in mole fractions, but we have mass, so double click on the top. Or I guess enter the first one. Now we can say erase, go to mass fractions, and you're going to do, for water, it's going to be 0.01, TEG 0.99, and we're going to hit OK. This is on a mass basis. Yes, double check. Now we're going to select our sweet gas stream, go to the attachments, and we're going to hit analysis, we're gonna click create and select hydrate formation. We're gonna hit add. And if you go to performance, you can see the specs. Something must have happened because it didn't solve, so let's take a look at that. So it looks like the issue that we had with our sat gas stream was that the temperature, I inputted it and it didn't save. So if that happened to you and your sat gas stream appeared light blue, meaning it didn't converge, you're gonna wanna double click on it and just double check that the temperature was 38. And if it did not save, go ahead and input that and it should all converge and all of your streams should be dark blue. So back to what we were talking about, if you go into your sweet gas stream, you double click that and you go to attachments, analysis, create, hydrate formation, add, you can see some of the specs from the performance tab right here. And we have the green bar that says okay at the bottom, so we're looking good. Go ahead, exit out of that. And we're gonna move on to the next step. Make sure to save your case as you go along. And just so we can see better, I'm gonna fit my screen. The next thing we're gonna do is add an absorber column, and these are gonna be our specs. So go ahead, back to the model palette, absorber column. We're gonna use this first one, double click, and I'm gonna input these specs. The name is gonna be TEG contactor. Number of stages is gonna be 8. Top stage inlet, TEG feed. Bottom stage inlet, sweet gas. Overhead vapor outlet is gonna be dry gas. We're gonna create a new stream for that. Bottom's liquid outlet is gonna be a rich TEG, new stream. So just go ahead and type that in. Then we're gonna hit next. Top stage pressure, 6125 kPa. Bottom is gonna be 6150. And we're gonna hit next. We're gonna leave the temperatures empty, hit done. Now in the parameters section, we're gonna hit solver. You can see our error tolerance here. Under heat spec error, right here, we're gonna change this from e to the -4 to e to the -3. The next thing we're gonna do is we're gonna run the column. So if you look at the bottom here, let me make it smaller. You can run the column like this. And let's see, we have an error. So let's double check what's going on here. So if you get an error like this one here, you might have to change the solving method. So we're gonna hit okay. For a solving method, we're gonna change it to inside out, modified HYSYM inside out. This one might be better, and we're gonna try to run again. And we see that our column converged. So yours might be able to converge with the original setting, but mine did not, and this one is more appropriate anyway. So if you just wanna do this from the beginning, that's okay. Now we can come out of here. We hit the X and we're gonna move on. To our next step, we're gonna add a valve. So go back to your model palette. Gonna search valve. I'm just gonna click this one first. The name, we're gonna leave it VLV 100. We're not gonna enter a pressure drop because that will calculate later. Our inlet is gonna be rich TEG. Outlet is gonna be LP TEG. And we're gonna leave it for now, even though it says yellow it will solve later. And we're going to add a heat exchanger. Back to your model palette, use this shown tube right here. And this is going to be our specs. So I'm going to go ahead and enter these in. Our inlet, we're going to call regen bottoms. Our outlet, lean from L-R. So once you've labeled these streams, you're going to go ahead and hit parameters. Our heat exchanger model, we're going to change from simple endpoint to simple weighted. Outside delta P, we're going to do 70 kPa, and the same for 2. Then in the worksheet section, under the regen feed, we're going to put our temperature to be 105 degrees C. And our pressure is going to be 110 kPa. So after we've done that, you can see that it's still not solved, but that's okay. We will solve that in the next step because our regen feed is solved and the bottoms and the lean from L-R are not solved yet, but that will come when we do the TEG regenerator column. So the next step is we're going to add a distillation column. Come back to your model palette. We're going to select this first one that comes up. And we're going to give the name TEG regenerator. Our number of stages is only going to be 1. Our inlet stream is going to be regen feed. Our condenser type is going to be full reflux. Overhead vapor outlet is going to be sour gas. Liquid bottom outlet is going to be regen bottoms. Condenser energy is going to be column Q. And then reb Q for our reboiler. You're going to hit next. Our reboiler configuration, we're going to leave it as once through regular HYSYS. Hit next. For our condenser pressure, we're going to put it to 96.5 kPa. Condenser pressure drop, we're going to put to 7 kPa. Reboiler, we're going to leave at 0, and our pressure automatically calculates to 103.5. You can hit next. We're going to leave our optimal temperature estimates blank. And then we're going to hit done. I'm going to make this smaller. This should pop up on your screen next. Under design and monitor, we're going to enter our specs here. So for the column temperature, we're going to go ahead, scroll down this way. We're going to do add spec. You're going to scroll down, column temperature, double click. This we can call for our condenser. So we're going to put the stage condenser spec value 102 degrees. We're going to add another one. The same thing, I can column temperature. We're just going to label it reboiler at the stage for the reboiler. and that's going to be 205 degrees C. So these status are going to be active. So go ahead, you're going to click the active, and then you can remove the check marks for overhead vapor, reflux rate, and bottoms product rate. And then for our reflux ratio, it's not going to be active. We're going to leave it as estimate. And we're going to specify the value to be 1 molar. It looks like that did not save. Okay, that's under estimate. Unconverged. Let's see what's going on. So if you have that error where it unconverges, it's possibly just because this calculated before we were able to specify our value. So if that happens to you, but your screen looks just like this, just hit the run button again and it will converge. So now we can X out of here and oops, we're going to go right back there for 1 second to our TEG contactor or regenerator, my apologies, because we're going to go to the parameters page and we're going to go to solver and we want to set the dampening factor to adaptive. So right here. And this will allow our convergence to be faster. And let's just run the column. We're looking good. So the next step we're going to do is a new material stream composed of TEG and water. So back a blue stream. We're going to call this makeup TEG. We're going to go to our composition. Make sure we're in mass fractions. Just to get in there, we're going to erase, make sure these are all empty under mole, select mass frac. For TEG, we're going to have it at 0.09. And then water is going to be 0.01. It adds up to 1. We're going to press OK. Go back to conditions. For our temperature, we're going to select 15.56 degrees C. And we are good. We're going to add a mixer now. Go back to your model palette, search for mixer, use this first one. And we're going to add in these specs. Our inlet is our let's rename this stream. Make sure that that stream we just made is called Makeup TEG. Mine didn't save the name. Now we go back into our mixer. Our inlets are going to be Makeup TEG and lean from L-R. Our L is going to be TEG to pump, which is a new stream. Under parameters, go ahead and we're going to set this to equalize all for our automatic pressure assignment. Under worksheets tab, for our TEG to pump, standard ideal liquid volume flow, we're going to set to 0.45 meters cubed per hour. One or more feet has negative flow. Let's take a look. So the issue that I was having was that I was stuck in hold, which sometimes that can happen by accident. I must have clicked something. which is why my mixer wasn't converging and the flow was going backwards. So just double check that. If you're ever on hold while you're actively editing and trying to get your HYSYS to solve, you'll give issues, double check here in your flow sheet modify tab. You want to be in active. So I went ahead and I did the next couple steps that I'm going to walk you through. So once you get your mixer to converge, we're going to add a pump. You're going to go ahead and type pump into your model palette over here. Click the first one and we can open up our pump. For our connections, our inlet is going to be TEG to pump, outlet is going to be called pump out, create a new stream. And our energy stream is going to be called pump HP. Then in our worksheet, we're going to go ahead and for pump out, we're going to define the pressure to be 6274 kPa. And then it should converge. The next step, we're going to add a heat exchanger. So go ahead, come back to your model palette. We're going to type heat exchanger and click the shell and tube once more. And for our heat exchanger, we're going to look at the connections and what we're going to define. Our inlet and outlet streams. So for tube side, we're going to define it to be pump out for outlet of our tube side, TEG to recycle, shell side inlet, dry gas, which we should already have, and then shell side outlet, a new stream called natural gas feed. In your parameters, go ahead and switch the heat exchanger model to simple weighted from the one that is default. And we're going to define shell side pressure drop to be 3450 kPa, tube side to be 69 kPa. Then under worksheet, go ahead and define the temperature for TEG to recycle at 50 degrees Celsius. And you should have it converged. The last thing is we're going to add in our recycle. So we're going to go to our model palette and we're going to search recycle and double click. Our inlet is going to be TEG to recycle, and TEG feed is going to be a new stream for the outlet. For parameters, we're going to go into our variables section. Our sensitivity is going to be changed to 1 for both the flow and enthalpy variables. Then for composition, we're going to set it to 0.1. Next, we're going to go to our main flow sheets because we are done here. And like I said earlier, under your flow sheet modify tab, there's a go to parent, which brings us right back to the beginning. And we're going to stay here on this window and we're going to go to connections, which is the default. In the outlet connections to sub flow sheet section, we're going to create an external stream called natural gas feed. So go ahead right here. And this will bring our material stream to our main flow sheet. And then under the transfer basis tab, we are going to set all non-energy streams as TP flash. Okay. And this will hold our temperature and pressure constant. And now we're going to move on to the next task where we're going to simulate the pre-cooling train. So now we're going to simulate the pre-cooling train. We're going to start by creating a new material stream in our parent, so a flow sheet. Click that blue arrow. We're going to name this MR Cool. And we're going to specify it with these specs we're given. Temperature is going to be 32 degrees C. For our mass flow, we're going to give it 1.4 E206 kilogram per hour. That should be a 4, not a 3. Then in our composition, we're given mole fraction, so we're going to hit edit. Mole fraction, nitrogen 0.0846. Methane is going to be 0.5053. Ethane 0.3383. Then for propane 0.0717. Ibutane 0.0001. And our total is 1, so we're looking good. Hit OK. And the pressure will be unknown for now, but that's okay. We're going to create a new blank subsheet. Come back over here, double click this. Start with a blank. We're going to name it pre-cooling drain. Natural gas feed and MR cool are going to be our inlet streams. Once we've added those in, we're going to go to transfer basis. For natural gas, select TP flash. MR cool we can leave as pH, and now we can go into our subsheet. So we're going to create a series of coolers right now. So go ahead into the model palette. And you're going to search chiller and select this, or cooler, and select this first one. And now we're going to go through and define them all. So for our first one, call it pre-chiller 1. Our inlet is our natural gas feed. Outlet we're going to call 30. Energy we're going to call PC1-Q. Under parameters, our delta P, we're going to call it 30 kPa. Under worksheet, for stream 30, our temperature, we're going to define it as 4.85 degrees C. And we are converged. Now we're going to add a second cooler. Come back and double click. This one is pre-chiller 2. Our inlet is going to be stream 30. Our outlet, we're going to create stream 31. Our energy is going to be PC2-Q. Under parameters, our delta P is again 30 kPa. And under worksheet, we're going to give our temperature for 31 negative 15.15 degrees C. And we are converged. One more cooler we're going to add. Pre-chiller 3. Inlet is stream 31. Outlet we're going to call to LNG section. Energy PC3-Q. Parameters delta P is going to be again 30 kPa. And under worksheet 2 LNG section, we're going to define the temperature as negative 35.15 degrees C. And we're converged. So as you can see, fully solved and defined. Now we're going to add 3 chillers for our MR cool. But it will not solve immediately, so don't worry about that. We're going to add another cooler, and we're going to define it as follows. Our inlet is MR cool, outlet is 32. Our energies, call it Q-HHP-C3. Parameters, our delta P is going to be 5 kPa. Worksheet for stream 32. We're going to give it a temperature of 4.85 degrees C. And we're going to move on to our next one. Add another chiller, MR chill 2, inlet 32, outlet 33. Energy Q-HP-C3, delta P 5 kPa. Worksheet temperature for 33 is going to be negative 15 degrees. And then our last one for this section, I'm just going to enter these specs over here on the right really quickly. So for our last one, the way I defined it is the same as they give us here for our specs, called MR chill 3, inlet stream 33, create an outlet MR cold, energy stream Q-MP-C3, and parameters, delta P is going to be 5, and in worksheet, MR cold temperature is going to be negative 35.15. So now we're going to go to our parent flow sheet. And under the Connections tab of the pre cooling train subflow sheet menu, we're going to create 2 outlet streams for the 2 LNG section and the MR cold. Then in our transfer basis, we're going to make sure that for both of them, they are pH, which they are already. So you can go ahead and exit out of that. We're going to refit our screen. Okay, the next thing that we're going to do, assign a pressure of 3218 kPa to MR cold. So double click that stream. We're going to go pressure, and we're going to define it as 3218 kPa. Hit enter. Looks good. It converged. Now all of our material streams should solve. So if we want to go double check into our, we can enter the cooling train subsheet. And you can see that all your streams are going to be dark blue. So everything's looking good. We can go back to our parent and continue on with the next task, where we convert the natural gas to LNG, where we're going to use a series of LNG exchangers. So go ahead and create a new subsheet. Start with a blank one. Double click it, and we're going to call this LNG section. To our inlets, we're going to add 2 LNG section and then MR cold. Double check they're both pH glass. Looks good. And we're going to go into our subsheet. First thing we're going to do is add a separator. So go back to your model palette. We're going to click this first one that comes up. Our name is going to be V103. Our inlet is going to be MR cold. Vapor outlet, we're going to call stream 14. Liquid, we're going to call stream 15. And now we can X out of this, and we're going to create a new material stream. Click that blue arrow. We're going to call it stream 20, and we're going to leave everything blank because it will calculate as we move along. And exit out of that. Now we're going to add an LNG exchanger. Go ahead and search that in your model palette. Double click. We're going to leave it as LNG 100 for the name. Under design and connections, we're going to list LNG, 2 LNG sections, stream 14 and 15 and 20 in our inlet. You can click add side for another inlet. Now we're going to create new streams called 3, 16, 18, and 9 in our outlets. So yours should look like this. 2 LNG is stream 3, 14 and 16, 15 and 18, 20 and 9. Now we're going to make our 14, 16, 15, 18, 2 LNG section 3 flows hot. So we just need to change this one. And then 20 and 9 is going to be a cold. So we're looking good so far. For our hot streams, our pressure drop is going to be 200 kPa. Oops. And our cold is going to have a pressure drop of 30 kPa. Now we're going to enter our worksheet tab. And for streams 16, 18, and 3, our temperature is going to be negative 87.15 degrees Celsius. Okay, the next thing that we're going to do is we're going to add a valve. We're going to leave it unsolved for now. So go ahead into your model palette, search valve, and we're going to name it valve 104. Our inlet is going to be stream 18. Our outlet is going to be stream 19. Under worksheet, we're going to do the pressure of 19 to be defined as 260 kPa. And now it is solved. We're going to add another mixer. So come back to your model palette. Mix 103 is what we're going to name it. Our inlets are going to be stream 19 and then new stream 17, not 167. Our outlet is going to be stream 20. Under parameters, we're going to set it to set outlet to lowest inlet for our automatic pressure assignment. Leave it for now and add another separator. We're going to call it V104. Our inlet is going to be stream 16, vapor outlet stream 21, liquid outlet stream 22, let's see what we got going on. We are going to add a second LNG exchanger. And these are going to be our specs. So I'm going to go ahead and define it. We're going to call it LNG 200. Our inlets, we're going to say 21, 22, 27, and 3. Then correspondingly for our outlets, we're going to do 23, 25, 17, and 4. For this combo, it's going to be hot. 22, 25 is also going to be hot. 27, 17 should be cold. 3 and 4 should be hot. For hot streams, pressure drop 200 kPa and cold 30 kPa. Under parameters, we're going to accept all the defaults, and under the worksheet tab, we're going to define streams 23, 25, and 4 to have a temperature of negative 113.7 degrees C. Next, we're going to add a valve. Come back to your model palette. Double click on the valve. And this is going to be decreasing, the pressure in stream 25 to 260 kPa in stream 26. So our inlet is going to be 25, our outlet is going to be 26. Then in a parameter, worksheet, our pressure is going to be 260 kPa for stream 26. Looks good. Next, we're going to add another mixer. Come back to your model palette. We're going to call it Mix 104. Streams 24 and 26 are going to combine into stream 27. We're going to leave the default settings and add a third LNG exchanger. We're going to call it LNG 300. Our inlets are going to be 23, 29, and 4. Our outlets are going to be 28, 24, 28, 24, and 5. For 23, 28, it's going to be hot. 24, 29 is cold, and 4, 5 is hot. Pressure drop 200 for hot streams and 30 for cold. We're going to leave the parameters alone, and under worksheet for the streams 28 and 5, we're going to define the temperature at negative 155.8 degrees Celsius. Okay. The next thing that we're going to do is add a valve. With 28 as the inlet, 29 as the outlet, and the pressure is going to be dropped to 260 kPa. And you can see that our flow sheet converged, so we're doing good here. Next, we're going to drop the pressure on the LNG stream and separate out the desired liquid. So we're going to use a valve and separator, and we're going to follow these specs below. I'm going to go ahead and input that, and I'll come right back. So you can see here that I added a valve. I named it valve 103, inlet stream 5, outlet stream 6. Then under worksheet, I defined the pressure of stream 6 to be 150 kPa. Then I added a separator, called it V105 with the inlet stream 6. Vapor outlet, called it 2 flare, and liquid outlet, called it LNG product. Everything is fully defined, and we're looking similar to what they have here. And so we can continue on. We can go ahead and hit the return to parent. Under connections, we're going to enter LNG product and 2 flare as external streams. In the outlet section, and then we're going to create an external outlet for stream 9, but we're going to call it MR return now. And we want to make sure that they're all set at pH flash, which they are. So we're looking good, and we're going to continue on to the next task. We're going to add another blank subsheet. Go ahead on your model palette, start with a blank. We're going to double click it. This one, we are going to title it Compressor Train Section. For the inlet connection, we're going to set it as MR return. And for the outlet, we're going to set it as MR cool. Let's verify they're both pH flash, that we are, and we're going to enter the environment of our subflow sheet. The first thing we're going to do is add a compressor via our model palette. We're going to call it MR comp 1. Our inlet is going to be our MR return. Our outlet is going to be MR comp 1 out. Our energy is going to be comp 1-HP. Under worksheet, we're going to give our pressure for MR comp 1 out to be 550 kPa. And the next thing we're going to do is add a cooler. We're going to reduce the temperature of our stream to 20 degrees with a 20 kPa pressure drop, and our outlet is going to be stream 10. So I'll go ahead and enter that, and I'll be right back. Okay, so we are going to continue with our HYSYS tutorial. I went and I was looking at the temperature increase of the stream, and even though that's not converged now, it will converge later. So we're going to continue on, and we're going to add the second compression stage and the aftercooler. So we're going to go ahead and we're going to add another compressor. We're going to double click. We're going to call it MR-comp 2. Our inlet is going to be stream 10. Our outlet is going to be MR-comp 2-out. Energy is going to be comp 2-HP. Then in worksheet, we're going to enter the pressure to be 2600 kPa. And we're going to leave that for now. Let me make sure that the next thing we're going to do is add another cooler, and this is going to be called our comp 2 cooler. With our inlet MR comp 2 out, our outlet is going to be stream 11. Energy comp 2Q. Then in parameters, our pressure drop we're going to say is 20 kPa. And then in worksheet, our stream 11 temperature is going to be 104 degrees C. Now we're going to add this last one, another compressor. MR-comp 3 with the inlet being 11. Outlet is MR-comp 3-out. Energy comp 3 HP. And then a final cooler where we're going to name it Comp3 Cooler. Inlet is our MR Comp3 out. Energy is Comp3 Q. Our outlet is MR cool. And then for parameters, our pressure drop is going to be 20 kPa. It looks good. So let's go and see that everything is fully calculated and looking good. So now we're going to go back to our parent flow sheet and we're going to see what we have. Let me make this a little bigger. And we're on to our last task, which is the refrigerant temperature control. So we're going to add and adjust operation to the main flow sheet. So we're going to select MR cool and mass flow as the adjusted variable. So the first thing that we are going to do this is we are going to search for adjust in the model palette, double click it. And we're going to select MR cool and mass flow as the adjusted variable. So we're going to come in here. Search in variables for MR cool. Oh, here we go. Here's our MR cool. And then we're going to select mass flow. Then the next thing we're going to do is define the target variable as MR return temperature. Next, we're going to enter a value of negative 48.15 as the specified target value. We're going to go to parameters, and we're going to set the max iterations to 100. And a minimum value of 1,000 kilogram per hour. And a maximum of 3 million kilogram per hour. Oh, it should be 100,000. And we're going to say, okay. And it converged, so that is going to be the end of our HYSYS tutorial. So you have just, if you followed all of the steps that we just went through here, you've just simulated a LNG process, which is a super important chemical engineering process where we take our natural gas feed and we compress it into liquid natural gas, which makes it easier for transportation and eventually customer use. So thank you for watching and have a great day.